Hey, we are going to look at slope-intercept form and sort of dissect it a bit and understand its amazingness and its awesome properties and go from there. All right, so we've already played around with intercepts for linear equations. We've already played around with understanding like them in context. We've looked at slope and looked at that in context and actually figured out how to like deal with it. And all of those things have to do with linear equations. Well, when it comes to linear equations, there's one format that works wonders in terms of graphing and in terms of interpreting it for slope and y-intercept, and that is called slope-intercept form. Slope-intercept form is awesome. I would have to say it's one of the more versatile formats of linear equations. That being said, you're going to learn two more forms of linear equations, both of which have pros to them and cons to them. But slope-intercept form has many more pros, in my opinion, than there are cons. Slope-intercept form, y equals mx plus b. That's its format. Now, what do each of these things mean? So we know our x always is our input or our independent variable. We've talked about this over and into, I can spell, independent variable. We've talked about this over and over in functions. We've now talked about it quite a bit in terms of slope and that sort of thing, but x is always going to be our input. If x is our input, we know y is the output, our dependent variable. We are essentially looking at whatever I put in for x, I should be able to manipulate this equation to figure out what y is. Now, m, we've talked about this quite a bit in terms of slope. We've talked about it in terms of m as well. M is our slope, so this is our ratio of our differences in our y's versus our differences in our x, our change in y over change in x, our rise over run, all that sort of stuff, that y sub 2 minus y sub 1 over x sub 2 minus x sub 1, slope. It's that big concept that we've been playing around with for the last couple of lessons. And this last thing right here, this b, and I have no idea why it's b. I'm sure somebody does. And I'm sure it's on YouTube. You could look it up. I mean, look it up. Tell me what it is. But b, this means our y-intercept. I just have no idea why we call it a b. I really should look that up before I post this on YouTube, but I'm going to post it on YouTube anyways. All right, so b is our y-intercept. This is essentially where our graph crosses the y-axis. What's awesome about slope-intercept form is when we have an equation written in slope-intercept form, we can super easily graph it. And if we can graph it, we can sort of get a visual of what the line looks like. We can see how steep or shallow it is. We can see where it crosses on the y-axis if need be, and sort of like see what that means in terms of this graph, if it's positive or negative, and all that jazz. So let's graph. Let's actually see this equation in action and see it in all its beauty. We have y is equal to 1/2 x minus 3 is our base equation that we are going to now graph. So whenever I use the slope-intercept form equation, I start always with the y-intercept. It gets me a starting point because otherwise I'm looking at slope and I'm trying to figure out where on this graph this slope of 1/2 is going to be, and it makes it really, really difficult. So you always have to have a starting point, and your starting point is always your y-intercept. If I look at this equation versus the base equation, my y-intercept, this one has a negative minus sign up in front. That means if I were to write it in its base equation format, 1/2 x plus, I'd add that -3 to my y-intercept. So I would say my y-intercept is 0, -3. It's that point. So now I'm going to take this point, because our y-intercept is where the x crosses, or where it crosses the y-axis, so x is 0. I'm going to find that point on my particular graph. So there's no movement along my x-axis. I'm going down 3 points on my y-axis, and I'm going to make a dot. That's where I'm starting. Then from there, I'm going to use my slope, and I love that it's already written in rise over run format, so I can already see the rise of 1 and a run of 2, and I'm just going to plot those numbers over and over again, and it looks like this. Let's see if I can do this in some color coordinating fashion. So I'm going to go up 1 unit, over 2 units, and that is where I'm going to make a dot. I'm going to go again up 1 unit over 2 units, and again, I'm going to make a dot. You can do this over and over, up 1 unit, over 2 units, and again, make a dot. And I can do this over and over and over and over again. I can even use this and go backwards. If I went up 1 unit, if I went down unit, I have to go backwards 2 units. So I could even go backwards and say, I'm going to go down 1 unit and to the left 2 units and make a dot. And now what I can do with all of these dots, because there's no limit on my domain, I can now connect the dots and create my continuous linear function graph in slope-intercept form. And now I have a line. Kind of cool. So this slope-intercept form is really nice for graphing. We're going to do a couple more practice problems, and we are going to graph a little bit more, and then you will be able to get into your must-do problems for this lesson. Thanks for watching. Bye.